Yo, Mr. Da Silva, listen, it's up in the air at this point. I haven't seen a breaker surge a wire and melt it like that before, but I also haven't seen a breaker in arc fault burn out the way it burnt out. He turned it on, it filled up, it smoked out, and it wouldn't reset when I got there when I cleared the short. So the breaker was unusable. When I took it out, it smelled like smoke. I couldn't see any damage on the exterior. I could break it open and see if the computer on the inside or whatever is on the inside of those breakers is melted or burnt. But the breaker's bad. Something went wrong with the breaker, whether the surge damaged the breaker or the breaker caused the surge, damaging itself and the wire. The only other thing I can think of is last week when there was a nor'easter here on the East Coast, a surge came back through the house. The only thing with that is I don't think the only one circuit and only the hot. It's not the neutral or, there was no damage on the neutral or the ground. It was the hot from the breaker to the switch box. And then that black wire spliced on with a bunch of other feed-ins and feed-outs. And only the feed out, so the feed in from the panel, black feed in from the panel was damaged, and the black feed out to one of the switches. There were two feed outs to both switches, and only the feed out to one of the switches was damaged. So something funny was going on. And I believe if it was a surge from the outside, from a transformer blowing or something, a lightning strike, there would have been a lot more damage than just that one black wire on that one breaker. Now, because that breaker burnt out the way it did, which I haven't seen before, so I'm assuming the breaker is what caused the surge. A lot of people are saying, well, the wire looks damaged, it looks skinned. All the copper that's shown on that black wire is from insulation being melted off from the surge. I know it looks like a razor blade kind of jumped down it. That's all melted wire. The razor blade did not jump down that. What happened is when that wire heated up, it burnt through all the bends in the wire first. So if the wire was bent real hard, the insulation was let's say thinner at that point, so that burnt quicker. When it heated up, that's the point that the copper broke through first, rather than a straight run where it wasn't burnt. So every bend in that wire, you can see the spots of where the copper's showing. And it melted from the switch to the panel, the whole black wire, to the point where the insulation melted off right where it goes into the outer jacket, touched the ground, caused the short. When the black melted enough where the insulation came off of the black, now the copper inside the black touched the copper ground, causing the short, tripping the breaker. So for some reason, if the arc fault sent out the surge, melted the wire, and then it shorted and tripped the breaker, and it all kind of did that simultaneously because it's so quick, that's the only thing I can think of. I can try to break that breaker open and see what it looks like on the inside. The only thing is then I won't be able to return it as a bad breaker. But maybe for educational purposes, I'll eat the $70. Now, a lot of people are saying if it was a bad splice, or even if the wire was nicked, or if someone hung a picture and hit it with a screw, you have to understand that's the only point that's going to heat up. If you have a bad connection or resistance in the wire where it's nicked, that spot heats up. It doesn't send heat back through the cable. It could, but it's going to heat up at that point first and most likely feel at that point before it gets hot enough to send heat back through the cable. You know what I mean? For example, if a wire was hit with a screw, it might heat up at that point, melt the insulation there first, causing a short at that point before it starts heating everything else up. Maybe it was a bad driver in one of the lights, and the driver caused the surge. That could be possible. We'll be able to figure that out when the new wire's in and we go to turn it on if the lights don't work and whatnot. But the reason I don't think it's one of the lights is because the wires leaving the switch going to the lights were not damaged. And if it was caused by the light, those wires would be damaged. So the only place it's damaged is from the breaker to the switch, which leads me to believe that it's the breaker that was the issue. If that makes sense. On a bad splice, if you have a bad splice, the splice is what's going to heat up. And it's going to heat up to the point where it's probably going to cause the feel at the splice. So even if the splice is loose and it starts heating up, right? It will start heating up back from that splice point, melting the insulation back and eventually causing a short within that box. It's not going to make it all the way back to the panel before there's an issue. It could. It absolutely could. I've never seen this before. The only time I've seen this before is on a job where there was a junction box that heated up, right? They had a Challenger breaker that would not trip, and they had 3 air conditions running. So the circuit was pulling 30 amps, and the breaker would not trip. The wire was 14 gauge, rated for 15 amps. 80% of that's like 12 amps is what the load calculation would be in the residential home that you're supposed to, build for. So it exceeded the 80% load calculation, 12 amps. It exceeded the 15 amps on the breaker nameplate. And then it exceeded well beyond that and was pulling like 26 amps or something for a long period of time. To the point where the black heated up so much that it melted and it touched the ground. And when it exploded, it cleared itself. Now, the black coming from the breaker stayed hot. It blew the ground off going back to the panel, but the ground going out to the circuit touched that hot wire, livening up the ground. And then the ground was live on a broken breaker, and it melted the insulation all the way through the outer jacket, right down. I got some pictures, hold on. So this is the box where the problem originated from. You can see the ground got so hot, it melted straight through this tape on the outside, and it has a black mark through the cable. Here's another view. It's all melting. So here was the failure point, right here. Now, the ground coming from the panel blew off. The black was still hot, touching the ground, livening the ground up. This might be going out. I forget if this was the failure point at the other end of it, but you can see the black line down the center of the Romex. Here, the ground heated up, came right out of the new Romex that was on the second floor. This is where I ended up originally finding the problem. It actually caught a piece of wood on fire in the attic. And look at the ground got so hot, it melted right out of the outer jacket. Now this is a different job, but just for an example, here's a bad connection where you have aluminum and copper spliced. It's heating up. It's melting the insulation, but it's heating up from this point. This insulation will melt and touch a ground long before it gets all the way back 30 feet to the panel. You'll have a failure starting from here. The surge, wow, I almost said thurge. Sound like Mike Tyson there for a second. The surge, right, heats up so quick that it heats everything up and then you have a failure. Where this is a slow burn, like you're smoking it. And it heats up at this point, slowly burns back and you have a failure.